In this video, we're going to talk about Invoke-RestMethod. We're going to look at what a REST API is, and then we're going to talk about the details of all the different ways you can use Invoke-RestMethod to call APIs from PowerShell. First, I want to talk a little bit about what REST is. REST stands for Representational State Transfer. The idea is that you have a separation between your client and your server application, and we communicate over HTTP. REST specifies a couple things. First, that separation of client and server. Second, it's stateless, so there is no necessarily any state communication between the client and server. The client and server communicate over HTTP using HTTP verbs, and we kind of use those in standard ways. The get verb is for returning a collection of resources or a single resource by ID. Post is used for creating a new resource. Put is used for updating a resource by ID, and delete is used for removing a specified resource by ID. So those are kind of standard CRUD functions, or create, read, update, delete. So in this video, we're going to actually use PowerShell Universal as a HTTP server, and then we're going to use Invoke-RestMethod to use it in a RESTful way. Let's talk a little bit about methods. Methods are the different type of HTTP verbs that you can use inside Invoke-RestMethod. So you can kind of think of these similar to PowerShell verbs, and they mean specific things across all REST APIs, or ones that are kind of standard. So we have a get, post, put, delete, and options for this particular URL. So this URL accepts all of those, and it'll just return the method that we pass in. So if we're using Invoke-RestMethod, what we can do is we can actually just provide the method parameter and then specify the method we want to provide. So you can see here post works and put works, and it's just outputting the method that we're passing in. So depending on the API that we're calling, it's going to change the behavior. As you can see in some of my methods here, I have get, post, and get, and they are using the same URL for some of these, but different methods. So this get URL, the idea would be that it returns users. And the post URL here is going to actually create a user. So we can actually do that. Right now, if I were to invoke my user API, I can do it without a method, and that is going to use the get method by default. So you can see here, right now I don't have any users inside my user table. But if I were to do a post, now you can see I did Invoke-RestMethod, the same URL, but a different method. So it's actually calling like a different bit of functionality. So you can kind of think of this as like new user versus get-user. And then I specified the body. So I'm just passing in a username of Adam. So now if I call my Invoke-RestMethod again, you can see that Adam has now been added to my database of users. So let's add Tom or something now, just to see what that looks like. So I've called the post again, which does a create on that particular user. And now when I call Invoke-RestMethod without the method parameter, it's using get, and it will return 2 users. So additionally, you can actually use APIs in this way. So with the REST API, you can see I have API v1 user, and typically after the user you can add a route parameter. Well, you'll see this very common in REST APIs, where the ID comes after the username. So you want to access not the full list of users, but you want to access a specific user. So in this particular API, I could put in 1, and now you can see it returns my user and not the full list of users. And if I put in 2, it would return the other user. So this is kind of an example of how REST APIs are laid out. You can have, one or more nested routes like this, and it kind of reads pretty well because you can say user / the ID of the user, and sometimes you'll see APIs where it'll be like user / group. So the idea is that the API is kind of discoverable. We have user ID 2, and we want to return that user's groups. So that's kind of how you can discover APIs and call them with Invoke-RestMethod. Another important concept with Invoke-RestMethod is the ability to understand status codes. So status codes pretty much dictate what happened when we ran the API. So a 200 status code means okay, and then pretty much everything else means something else. So there are informational and successful response codes. So if you look at some of the response codes, like 200 is the one you'll usually see. If you do a post or a put, sometimes you'll see a created or an accepted, or even a no content. So there are a bunch of different status codes in the success range. More commonly, what you have to deal with are error codes. So bad request means the server got something it didn't expect. Unauthorized means that you're not authorized to access it, which typically means that you're not authenticated. Forbidden means that you're authenticated, but you're not authorized, so you don't have the correct privileges. So you have, you're logged in, but you don't have the correct privileges. Method not allowed means you're calling the correct API URL, but it is the incorrect method. So there might be a get URL, and you're putting in a post, and it just doesn't accept it. But my favorite one is I am a teapot. So if you actually call Invoke-RestMethod and you get a 418 error code, that means the server is a teapot. So let's see what this looks like. It's actually kind of funny because that's an actual real RFC'd status code. So I have a status code API, and in this API, pretty much what I'm going to do is I'm going to pass in a status code, and it's going to do something to Invoke-RestMethod. So when I do a 200, you can see nothing happens. It said it was okay. I didn't return any data or anything, so I didn't get any errors or anything like that. Now, if I do a 400, you're going to see that I get a 400 error code here, and it says bad request. So typically, if you get a bad request, that means that the server didn't like what you sent it. And if I send it 401, I'm unauthorized. 403, I'm forbidden, and of course we need to check 418, which is I am a teapot. Finally, another common error code you're going to see is a 500 error code, and that means internal server error. Typically this means that the server actually faulted and it was unable to return an actual error code, and this is something you typically want to go and complain to whoever's API you're using that their server is throwing an error. Now I want to talk about content that's returned from a request. So in a RESTful world, pretty much what will be returned from requests are entities. So you can think of them as users or groups, things that you create, not like an actual web page, an actual JSON string or XML string that then you can manipulate or convert into an object. And that's where Invoke-RestMethod actually is really handy because it does a lot of that automatic conversion for you. So there is also Invoke-WebRequest, but you actually have to take the content and parse it yourself, and that's where Invoke-RestMethod has been developed to actually do the parsing for you. So I actually have another method here, and this one is just called the content, and the idea is that you can pass in a type route parameter, and you can either return JSON, XML, or text. So if I pass in JSON, it's going to convert JSON, or this hash table into JSON, and then it will pass out the content type header for this data. So that tells Invoke-RestMethod that this is JSON and you should treat it like JSON. In the other condition, we're actually going to use XML, and I have a little XML here, and then I'm setting the content type to text XML. And again, that tells Invoke-RestMethod to parse it as XML. And finally, I am setting some plain text, so that tells Invoke-RestMethod to do nothing with it but display it as a string. So there's lots of MIME types that could be passed in, but these are some of the standard ones that you're going to run into with Invoke-RestMethod. And what's kind of nice about it is that you don't have to worry about what's being returned all the time to actually get a rich PowerShell object back. So let's go back to our terminal here. And I am going to do Invoke-RestMethod, and I'm going to do content/JSON. And now you can see that hello world was returned back to me, and it was returned back as an object. So rather than returning the JSON string, Invoke-RestMethod took that, saw that it was application JSON, and deserialized it to a PS object for us. It does the same thing for XML. So if I actually do Invoke-RestMethod XML, you can see that it took that XML string that I had inside my endpoint and converted that into an object. Now it's a little different when we do just text. You can see that in this case, it just returned hello world. So it was just a plain text string, and you can do that what you will, but it doesn't do any additional processing because it realizes it's plain text and it shouldn't do any kind of conversion. When sending data with Invoke-RestMethod, you have to be aware of the actual content type that you're sending up to the server. By default, it actually uses form encoded data rather than JSON, which you'd kind of expect it to do. it kind of threw me off when I first started using Invoke-RestMethod and it wasn't using JSON by default. So for example, I have an endpoint here, and this endpoint is just a simple form post endpoint, and the URL is localhost 5000/form. And using Invoke-RestMethod, what I'm actually going to do is a post, and I'm going to pass in a hash table. So when you do it like this, what it's actually going to do is it's going to turn that into a form encoded string that you can kind of think of that as you're on a website, you've typed in your username and password, that's sending form encoded strings to the server, and then you can kind of take that apart on the server end and do it with it what you will. So by default, Invoke-RestMethod does that. So let's just take an example, or this example, and see what that looks like. So I'm going to call Invoke-RestMethod. I've got my log open, and I'm going to write out the host content type. So that is the content type that's passed in automatically. There's actually a parameter that you can specify, which we're going to do in a second, but I'm just leaving that blank for now. So when I invoke that, you can see that it said, hello, Adam Driscoll, and based on the logic of my endpoint, we got first name and last name, and then we print out that string back to the client, but we also used write host to write a little log message to the server. And you can see that we have write host, headers, content type, and the content type is application x www form URL encoded. So that is a form submission. And this is what the URL encoding looks like. It's a bunch of name value pairs. So we have first name equals Adam and last name equals Driscoll. So that was the actual body of the message that was sent up. So if you actually want to send JSON, what we need to do then is specify the content type. So I have another endpoint here, and you can see this endpoint is very similar to the previous one. I'm going to print out the content type. I actually might print out the body just so that we can see what that looks like. We'll save that. And now I am going to send some JSON with Invoke-RestMethod. So rather than calling it without the content type, I am going to call it with the content type. So this is similar and kind of in the way that I'm using a hash table, but I'm taking it one step further by converting to JSON. So I have Invoke-RestMethod. I'm calling my JSON endpoint. My method is post. The body is in these parentheses, and it's taking a hash table with the message, welcome to the rodeo, and converting it to JSON. Finally, I have the content type attribute here, or parameter here, and I'm specifying application JSON content type. So now you can see it said, welcome to the rodeo. I should have been in the log tab, so we'll just do that one more time. And now we can see that the content type was application JSON because we specified it on the commandlet, and then the message was formatted as a JSON string. Inside my method here, I converted from JSON back to an object, and then I printed out the message that was sent. The other way that you can send data to a server is via files. So Invoke-RestMethod and Invoke Web Request kind of work the same way in this regard. They have an in-file and out-file parameter. The in-file will upload files to the URL you're specifying, and the out-file will take files that are sent down from that particular URL and write them to a path. So I have an endpoint here, and this endpoint is just a post with a URL of /file. And I am going to send a file up to this URL. And the idea with this code right here is it's going to accept a file, it's going to create a temporary directory, it's going to take that file that was uploaded, write it down to disk, then it's going to use the compress archive commandlet to take the folder and file that were uploaded, compress those into a zip, and then send those back down as the request. So it's kind of like a compression API. So in order to call that from Invoke-RestMethod, it's actually pretty easy, and you can do that with in-file and out-file. So I'm calling my file API. My in-file is just some markdown file that I have in here. I think it's a help for select node. And then finally, I'm using out-file to output the file once it has been compressed on the server. So I'll invoke that, and you can see it processed the bytes, so it uploaded the file, downloaded the file, and if I go to my desktop somewhere, wherever that is, you can see I have file.zip now, and it has my random folder name, and it has my random file that was compressed into it. So this is actually that markdown file, and I could open it, and it would still be a markdown file. So that's just another example of how you can communicate with REST servers using files. Another important concept when dealing with REST APIs are headers. Headers are additional information that are sent with HTTP requests, and they include things like where it's coming from, the user agent, which is typically the browser that's being used, and that kind of thing. And you can actually see this in web requests. So if I open my network tab here and I do a reload on PowerShell Universal, you're going to see that it makes a whole bunch of web requests. And each one of these web requests actually has request headers. So that's what we're going to be working with right now. You can see things like what type of content type it supports, what type of encoding it supports, gzip, that kind of thing. And as I mentioned, things like the host, like where it's coming from, and the user agent string is always kind of interesting because it has a bunch of information about typically the browser and the operating system. So what we're doing in this method is we're actually just calling Invoke-RestMethod, and we're just echoing the headers back out. Headers is just a hash table we automatically populate, and we're going to see what headers Invoke-RestMethod actually sends by default with each request. So if I actually grab this Invoke-RestMethod call here and put it into my terminal, you're going to see that the output are just a couple of headers. So it's setting the host header and it's setting the user agent header. And you can see here that the user agent is PowerShell /7.2.3. And it also includes information about the version of Windows. The content length is 0 because I didn't specify any type of body with that request. This will be the number of bytes that the body consists of. So with Invoke Web Request, REST method, you can also include your own headers. So some web servers may have, or APIs may have certain things that you have to specify via the headers. We'll see this with credentials and stuff like that, but this is just an example of some random header I created called my super cool header, and then I'm specifying my super cool value. So headers is just a hash table of key value pairs, and that will be passed in via the headers of that web request. And then in this case, it's accessible in PowerShell Universal, but you might have it accessible in whatever web application you're dealing with. And again, it's just printed out because we're just printing out the headers. Another way to send things to APIs is via query string parameters. Query string parameters sometimes are optional, I think typically, just because they're kind of hard to determine without any API documentation. So you'll see query string parameters for things like paging, queries, sorting, that kind of thing. And they are the question mark after the URL. So I have a really simple API here that just accepts a query and a page parameter. And we can just call that via the query string URL here. So if we go to Invoke-RestMethod to use a query string parameter, it's really easy because you just formulate it like you would in the browser. So you just have a question mark followed by the query string value, which in this case is, or key, which is query, and then followed by an equal sign and then the value of that query string. So if we hit enter there, you'll see that this is a query is returned because that was passed into the API from the query string parameter. You can specify multiple parameters with Invoke-RestMethod using the and operator here. So pretty much it says $sign or question mark query equals and the key equals the value. So you can put lots of them. You could just keep going. But in this case, we're using 2, and then you can see the API output those 2 values because it passed in those 2 parameters. One thing to note, which always catches me off guard a little bit, is you can get away with doing something like this in PowerShell. So I can pass in the query string parameter, but as soon as you try to do something like this without quotes, you're going to notice that the color changed with PS readline, and if you try to execute it, you're going to get kind of a weird error, like, why didn't this work? Started a background job and stuff like that. So you got to be a little careful because it's treating that ampersand as an execution. So you make sure you wrap it in quotes when you're setting your URL. Another important concept to understand when dealing with Invoke-RestMethod and HTTP servers are cookies. So you probably see a lot of pop-up about cookies nowadays, and that's because cookies can track your state. The idea with a cookie is that you can get a response cookie where it will save it to your browser, and that could contain information about you. And then depending on how that cookie is defined, it's going to share that cookie with that web server, and like as you move around the internet, that cookie can use to be tracking you. So that's why cookies are bad nowadays. But cookies are still pretty common. If you have cookie authentication on, which is our default for PowerShell Universal, you're going to get this ASP core cookie, and it's going to be set to this value. And this cookie is only communicated back and forth on localhost. So cookies typically have a domain set to them, and the browser will send that cookie back to the server only if you're accessing that particular domain. So I have a really simple PowerShell Universal cookie example here. So if you call this API, it's going to return a response cookie, and that response cookie would be stored in the browser. So I think, I didn't test this, but I'm going to open a new tab, and we're going to see what happens. If I hit this cookie, and we actually open this page, you can see my cookie is now set. So I actually downloaded and loaded that cookie into my browser. So my cookie is now set in my browser. But with Invoke-RestMethod, we need to be able to store that cookie somewhere. Because if you use Invoke-RestMethod, it's pretty much stateless. It doesn't like maintain cookies or sessions or anything like that. But you can do that using the session variable and web session parameters. So these parameters are the same on Invoke web request as they are on Invoke-RestMethod. So I'm specifying a session variable of my session. You don't want the $sign in front of there. That'll be null. You want an actual string of the variable that it's going to set. And again, I'm going to be hitting that cookie URL now. So if I hit Invoke-RestMethod there, nothing's going to happen because I don't really return anything from that. But you can see that my session has now been created. So my session could have headers, you can see the user agent, and it also has a cookie container. So using that cookie container, we can actually get all the cookies out of that cookie container using the getAllCookies method. And now you can see that my cookie was set into this particular session. So cookies, I think the main reason you're going to use them in Invoke-RestMethod is for authenticating. So you might call, this instead of a cookie method, you might call a login method, store that cookie for that login in the session variable, and then your subsequent Invoke-RestMethod calls, you're going to want to pass in the web session. So to do so, what I want to do here is not type cookie, but I actually want to type Invoke-RestMethod, and it should be my session, not session. And it's going to use that session variable for the next Invoke-RestMethod. And it will continue to collect cookies and that kind of thing inside that web session if you keep using the web session. But if you are going against an authenticated application interface, you're going to need to potentially use a session like this to do so. Now we're going to look a little bit at authentication. One way that is pretty common for you to have to authenticate with REST services is via app tokens. App tokens or Java web token or JavaScript web tokens or JWTs, you might see them. Personal access tokens is what they're called sometimes. And these tokens are used to allow services to communicate based on your user account. But what's cool about tokens is that you can cause them to expire, you can revoke them in case something happens, and you can limit the scope of access the token actually has to things in your account. So you might not want a token to have full admin access, you might just want it to have some operator access or something like that. So PowerShell Universal actually has the concept of app tokens, and you can see here I've created a basic app token that never expires and is an administrator. So most powerful app token ever, probably not very secure. So what an app token looks like is, I'm going to store it in a variable, and you can see it's just a big string of characters. Depending on the tokening system, it might be shorter or longer. This is just the standard JWT. So now that we've stored that there, we can actually use it to call our secret API inside PowerShell Universal. So I have this Invoke-RestMethod call. It calls my secret endpoint. And if I call that without specifying any kind of authentication, you're going to see that I get a 401 unauthorized. But if I actually specify my JWT on here, I can invoke that API. So in order to specify JWT, you're going to set the authorization header, and you're going to use the bearer verb for this, and we're going to pass in the app token variable. So make sure you have a space in between bearer and app token. And then when I hit enter, you can see I got the secret and I was authenticated against PowerShell Universal. Another common method of authenticating against REST APIs like this, especially in the Windows world, is to use default credentials. So default credentials or Windows authentication or single sign-on, as you might hear it, is pretty common. And typically that is either NTLM or Kerberos or negotiate. It's kind of a bunch of different words they use for this type of authentication. But Invoke-RestMethod refers to it as use default credentials. So I have Windows authentication enabled inside PowerShell Universal here, and I can actually use Invoke-RestMethod to call my secret API using default credentials. So do note that I have the allow unencrypted authentication setting on here. If I take that off and try to run this, it's going to complain because I am on HTTP. You will not need to include that if you're going against a server that has an SSL certificate. So if I put that on there and then use my default credentials, you can see that I can access my secret, and it kind of automatically did the credentialing for me via the negotiate and NTLM or Kerberos protocol, depending on how you're accessing this server. Now I want to talk a little bit about some resiliency parameters for Invoke-RestMethod. We're going to look at retries, redirects, and timeouts. So I have an API that will randomly fail. So if I actually invoke this API with the just by itself, you can see that I got a bad request. So 20% of the time it's going to return success, and 80% of the time it's going to return failure. So you can see there I got two good ones in a row and one bad one. There you go. To avoid having to actually do this myself over and over again, what you can actually do is you can include retry counts and the retry interval sec. So that is the number of seconds to wait before retrying and the maximum number of times to retry. So I've included the verbose parameter here so that we can actually see it trying to do that retry. If you don't, it's just gonna kind of internally do this. So now you can see that it's retrying after each bad request. And after the fourth request there, you can see the fourth request was actually returned true, or returned successfully. Another thing that you can use Invoke-RestMethod for is following redirections. So I actually have an API inside PowerShell Universal that it redirects to another API. So I have redirect, and you can see here that it's returning a 301 status code, which is a redirection status code. And then in the headers, I'm saying where to redirect to. So the location header is a standard header that you'll see. And then inside there, I'm actually calling the redirected API. And then the redirected API, all that does is it returns, I think, the string redirected. So we'll know we hit that API if we see the redirected string. So if we go to Invoke-RestMethod, there is a parameter called maximum redirection. So this allows you to specify how many redirects to follow. So redirects can be slow depending on where it's redirecting you to. So you may or may not want to redirect a bunch of times. And if we set this to 0, what you're going to see is that I called random. I got to call redirect. You can see that it's 301 moved permanently. So we got the redirection, but we didn't follow the redirect because I set the maximum redirection to 0. If I increase that by 1, so the maximum redirection is now 1, you can see that I got redirected. And it kind of did that internally. I think if we do verbose, it'll show us that we were redirected. It does not. But yeah, so the idea there was we hit the first API, it says redirect to this other API, and then Invoke-RestMethod automatically followed that redirection. The last parameter that you can specify for kind of resiliency is a timeout. So I don't actually know what the default is for this, but depending on the API you're calling, you may not want to wait a minute or two for it to return. So Invoke-RestMethod actually has a timeout parameter. So I have an API that just sleeps for 10 seconds called timeout, and if I call that, we could wait the full 10 seconds, I think, if we were to get rid of the timeout sec parameter here, but I'm going to set it to 1. It's going to only wait 1 second to see if it times out or not. And you can see that it actually canceled this because the timeout was set to 1 second. And once that elapsed, it timed out this particular REST API call. In this video, we went over how to use Invoke-RestMethod to call REST APIs from PowerShell. I hope you learned a lot from this demo, and if you have any questions, please put them in the comments below. And if you like videos like this, definitely subscribe to my channel.